Tissue. Organisms are of two types: unicellular and multicellular. Unicellular organisms are able to do all the life processes such as digestion, respiration, excretion, reproduction by themselves. Multicellular organisms have different cells to perform different functions. The body of a simple organisms like Hydra is made of different types of cells, and the number of cells in each type can be thousands. Human body is made by billions of cells organized into about 200 different types, performs various functions. A group of cells having the same embryonic origin, structure and function along with intercellular fluid is called tissue. But in tissue, cells may be different in structure and function, but they are always similar in origin. Word animal tissue was coined by Bichat, plant tissue N. Grew. Study of tissues histology, Father Bichat. Detailed study of tissue is called microscopic anatomy, founder Marcello Malpighi. Animal tissues are of four types. 1. Epithelial tissue covering and protective tissue. Origin: all, endo, meso and ecto. 1. Connective tissue to connect structures. 1. To provide support to the body. 1. To transport substances in the body. Origin: mesoderm. 1. Muscular tissue perform contraction and relaxation which helps in movement and locomotion. Origin: mesoderm. 1. Nervous tissue. 1. To generate and conduct impulses in the body. Origin: ectoderm. Epithelial tissue. General characters. Epi, upon, thelia, growth. A tissue which grows upon another tissue is called epithelium. During embryonic development, this tissue originates first. Epithelial tissue is commonly termed as epithelium. This tissue has originated from all the three primary germ layers. This tissue has a good power of regeneration, which is absent or least in nervous tissue. This tissue has a free surface, which faces either a body fluid or the outside environment, and thus provides a covering or a lining for some part of the body. This tissue always rests on underlying connective tissue. Epithelium is the only tissue in which cells are always arranged in a uniform layer. An epithelial cells is very compactly arranged, so there is no or little intracellular space or matrix present. Due to compact arrangement of cells, no intracellular spaces. So blood vessels can't pierce the epithelium. So epithelial tissue is avascular in nature. Are they vascular? They get nutrients from the underlying connective tissue. Between epithelium and connective tissue, a thin non-living, non-cellular basement membrane is present which is highly permeable. Basement membrane is secreted by both epithelial and connective tissue and made up of glycoprotein, mucopolysaccharides and protein fibers. Basement membrane is made by two layers. Basal lamina, it is made by glycoproteins secreted by epithelial cells. Reticular lamina, it is towards the connective tissues, in which matrix is secreted by fibroblast, and in that matrix collagen and reticular fibers are suspended. Matrix is mucopolysaccharide which is in the form of hyaluronic acid. Cell junctions. All cells in epithelium are held together with little intercellular material in nearly all animal tissues. Specialized junctions provide both structural and functional links between its individual cells. Cell junctions in epithelium. A tight junction help to stop substances from leaking across a tissue. Prevent lateral diffusion of protein and ions. Found in stomach, small intestine, urinary bladder. B. Adherence junction perform cementing to keep neighboring cells together. Involved in various signaling pathways and transcriptional regulations found in epithelial cells. C. Gap junction facilitate the cells to communicate with each other by connecting the cytoplasm of adjoining cells for rapid transfer of ions, small molecules and sometimes big molecules and chemical messages between cells. Found in lens, cornea, epithelial tissues. D. Desmosomes, they provide mechanical strength to epithelial tissue, cardiac muscles and meninges. Protein plaque, intermediate filament, on skin, in heart muscles. A. Hemidesmosomes allow the cells to strongly adhere to the underlying basement membrane. These maintain tissue homeostasis by signaling to anchor the epithelial tissue to the basement membrane. F. Interdigitation, finger-like projections of plasma membrane which enters into cytoplasm of adjacent cells. Plasma membrane of free end get modified in three types of functional structure. Microvilli. I. Minute process. E. Non-motile. E. Non-contractile. IV. Function increase surface area for absorption and secretion. X. Wall of intestine, gallbladder, PCT of nephron. Cilia, kinocilia. I. Long cylindrical process, same diameter from base to apex. E. Motile. E. Contractile. IV. Function helps in movement and locomotion. It moves particles or mucus in a specific direction over the epithelium. X. Inner surface of hollow organs like bronchioles and fallopian tube, uterus, trachea, ependymal epithelium, inner linings of brain cavities or ventricles and central canal of spinal cord. Stereocilia. I. Conical shape. E. Non-motile. E. Non-contractile. IV. Function increase surface area. X. Epididymis and vas deferens, crista and macula of internal ear. Origin of epithelial tissue. It is the only tissue which originated from all the three primordial germinal layers. X. 1. Ectodermal, epidermis, stratified squamous epithelium. 2. Mesodermal, mesothelium, protective membrane that covers linings, abdomen, heart, testes. Endothelium, simple squamous epithelium, constitutes the inner cellular lining of heart, blood vessels, lymphatic system, which is in direct contact with body fluids. 3. Endodermal, gastrointestinal tract, simple columnar epithelium. A. Simple epithelium. I. Simple squamous epithelium, single thin layer of flattened cells with irregular boundaries. Found in blood vessels and air sacs of lungs and are involved in a function like forming a diffusion boundary. Also see, as pavement epithelium. Due to its tiles-like appearance. Also see, as tessellated epithelium. Due to its wavy appearance. It is associated with filtration and diffusion. Occurrence. Outer surface of intestine Bowman's capsule, podocytes. Alveoli of lungs, air sacs of lungs, mesothelium lining of coelom is called as mesothelium endocardium, innermost lining of heart. The part of loop of Henle of nephron peritoneum lining of abdominal cavities. 2. Simple cuboidal epithelium, composed of a single layer of cube-like cells. Cells are cube-like with a rounded nucleus present in the center. Cells are the same in length and width, so appear square-shaped in vertical section. This epithelium helps in absorption, secretion. This epithelium is also called germinal epithelium because in gonads, testes and ovaries, cuboidal cells divide to form sperm and eggs. Occurrence. Follicle of thyroid gland. Acini of pancreas. Secretory unit of sweat gland. Iris, choroid, ciliary muscles of eyes, epithelium of retina. DCT of nephron. Thick part of loop of Henle. Modifications of simple cuboidal epithelium. A. Brush-bordered cuboidal epithelium. When microvilli are present on the free end of cuboidal cells, then it is called brush-bordered cuboidal epithelium. Found in PCT of nephron. B. Ciliated cuboidal epithelium. When cilia are present on the free end of cuboidal cells, then it is called as ciliated cuboidal epithelium. Found in collecting ducts. 3. Simple columnar epithelium. Composed of a single layer of tall and slender cells. Their nuclei are located at the base. Free surface may have microvilli, lining of stomach and intestine help in secretion and absorption. If columnar and cuboidal cells have cilia on their free surface, then they are called ciliated epithelium. Occurrence. Liver. Bile duct. Uterus. Modifications of simple columnar epithelium. A. Brush border columnar epithelium when microvilli are present on a free surface. Gallbladder helps in concentrating bile juice. B. Glandular columnar epithelium, unicellular mucus secreting goblet cells are also present between columnar cells. Stomach, cecum, colon, rectum. C. Glandular brush border columnar epithelium, when microvilli present on the free end of columnar cells and in between these cells goblet cells are also present. Small intestine, duodenum, jejunum, ileum. D. Ciliated columnar epithelium, when cilia are present on the free end of columnar cells. Fallopian tube, conduction of gametes, bronchioles. A. Pseudostratified epithelium, it contains long and short cells. Nucleus of both cells present on different levels, so it appears bilayers because few cells are too short to reach the top surface, but all cells are present on single basement membrane, so it is monolayered. Respiratory epithelium of nasal chamber, trachea, bronchi. B. Compound epithelium, made up of more than one layer, multi-layered, of cells and thus has a limited role in secretion and absorption. Their main function is to provide protection against chemical and mechanical stresses. They cover the dry surface of the skin, the moist surface of buccal cavity, pharynx, inner lining of ducts of salivary glands and pancreatic ducts. On the basis of stretching ability, it is of two types. 1. Transitional epithelium, stretchable. 2. Non-stretchable. 1. Transitional epithelium, urothelium. In this epithelium, basement membrane becomes invisible during stretching. In this epithelium 4-6 layers of cells are present. These different shapes of cells appear only in the resting stage. When this tissue is stretched, all the cells become flattened. Cells are interconnected by interdigitation. Stretchable and waterproof. Occurrence: renal pelvis, ureter, urinary bladder, proximal part of male urethra. 2. Non-stretchable epithelium. On the basis of the shape of the cells of the outermost layer, it is of three types. A. Stratified squamous epithelium. B. Stratified cuboidal epithelium. C. Stratified columnar epithelium. A. Stratified squamous epithelium. Innermost layer of cells are cuboidal. They divide to form cells of the outer layer in the epithelium, so this layer is called the germinativum layer. Middle layers are interconnected with desmosomes which provide rigidity or mechanical support. Cells of the outermost layer scale like flat cells. On the basis of presence or absence of keratin protein in the outermost cells, this epithelium is of two types. Keratinized stratified squamous epithelium. If keratin protein is present, cells become non-nucleated and dead. Epidermis of skin and skin derivatives: hair, horns, hooves, scales, feathers. Non-keratinized stratified squamous epithelium. If keratin protein is absent, cells are nucleated and living. Lines of moist surface of buccal cavity, pharynx, esophagus, anal canal, vagina. Cornea of eye, conjunctiva of eye, inner lining of cheeks, lips, hard palate. B. Stratified cuboid epithelium. Cells of outermost layer are cube-like, nucleated and living occurrence. Secretory duct of sweat glands, mammary gland, salivary gland and sebaceous gland, pancreatic duct. C. Stratified columnar epithelium. Outermost layer is composed of pillar-shaped cells. Cells are nucleated. On the basis of cilia, this epithelium is of two types. I. Ciliated, larynx, buccopharyngeal cavity of frog. E. Non-ciliated, distal part of male urethra, epiglottis. Glands. Cells or a group of cells, which secretes chemical substances, are called glands. All glands are composed of epithelium. Glands can be originate from all the three germinal layers. Ectoderm sweat gland. Mesoderm thyroid gland. On the basis of number of cells, glands are of two types. 1. Unicellular glands X, goblet cells, Paneth cells. 2. Multicellular glands X, all glands except goblet cells, Paneth cells. Types of glands shown on screen. Read the flow chart of glands. Structure of exocrine gland. The structure of the exocrine glands is divided into two parts. 1. Ductal portion. 2. Glandular portion. 1. The ductal portion is tubular in shape. It is a single, thick, cuboidal cell wall that helps in the movement of the secretion. The duct may be branched or unbranched. It can also be found as a simple coiled structure. 2. The glandular portion is responsible for the production of the secreted substance. It is a circular or elongated cluster of cells. The cells found in the glandular portion depend upon the substance secreted. For e.g., serous cells secrete proteins, mucous cells secrete fluids. Functions of exocrine glands: black small square regulate body temperature, black small square lubrication, black small square lactation, black small square helps in digestion, black small square helps in reproduction. Types of exocrine glands. The exocrine glands are of three types on the basis of mechanism of secretion. A. Merocrine, eccrine glands. The substance is secreted directly into the duct through the cellular channels. There is no rupturing of cell membrane involved. B. Apocrine glands. They bud off a part of their cellular cytoplasm and membrane and release the substance into the ductal system. C. Holocrine glands. These are released by the rupture of the plasma membrane. Produced in the cytoplasm of the cell, these destroy the cells and secrete the product in the lumen. Examples of exocrine glands. 1. Lacrimal glands include tear ducts near each eye, above upper eyelid. They create and secrete a fluid that gets into your eyes every time you blink. This fluid helps keep your eyes moisturized. 2. Meibomian gland present in eyelid, secretes lipid that forms superficial layer of tear film to protect evaporation of the aqueous phase. 3. Pancreas secretes pancreatic juice along with the digestive enzymes into the stomach. I. Lipase, breaks down fats into fatty acids. E. Protease, trypsin and chymotrypsin, breaks down proteins into amino acids. E. Amylase, breaks down carbohydrates into simple sugars. Position. Pancreas sits behind your stomach and in front of your spine. Your gallbladder, liver and spleen surround your pancreas. Disorders. Type 1 diabetes occurs when your pancreas doesn't produce insulin. Type 2 diabetes occurs when your body makes insulin but doesn't use it correctly. Hyperglycemia happens when your body produces too much glucagon. This results in high blood sugar levels. Hypoglycemia occurs when your body produces too much insulin. It causes low blood sugar levels. Pancreatitis happens when enzymes start to work in the pancreas before they reach the duodenum. It may result from gallstones or excessive alcohol. Pancreatitis can be temporary or long-lasting, chronic. Pancreatic cancer. Cancerous cells in the pancreas cause pancreatic cancer. Pancreatic cancer can be difficult to detect and treat. 4. Salivary glands secrete saliva along with digestive enzymes. There are 3 major pairs of salivary glands. SAD phase. I. Sublingual glands. These are below either side of your tongue, under the floor of your mouth. E. Submandibular glands, located below your jaw. Like sublingual glands, the saliva produced in submandibular glands enters the mouth from under your tongue. E. Parotid glands. Parotid glands are just in front of the ears. Similar to submandibular glands, the saliva produced by your parotid glands enters the mouth from small ducts near upper molars. It is the largest salivary gland. Functions of salivary gland: contains an enzyme called amylase, which helps your stomach break down starches into simple sugars. Keeps mouth and throat lubricated and comfortable. Moistens food so it's easier to swallow. Keeps mouth clean. Helps reduce risk of cavities and gum disease. Helps maintain the pH balance in mouth. About salivary gland: saliva is colorless, viscous fluid with pH 6.8. Saliva contains thiocyanate, which fight with pathogen. Saliva contains lysozyme, which is bacteriolytic. In adults, salivary glands produce about 1 to 2 liters of saliva every day. During the average lifetime, salivary glands will produce over 23,000 liters of saliva. Saliva is 99% water. The rest consists of proteins, enzymes, mucus and buffering agents. Just 1 drop of saliva contains a sample of complete genetic makeup. Without saliva, wouldn't be able to taste food. The molecules in food must dissolve in saliva before taste buds react. Swelling in salivary gland. Several different conditions can lead to salivary gland swelling. For example, swollen parotid glands are the hallmark symptom of childhood mumps. This condition is far less common today due to the MMR vaccine. Mostly mumps occur through paramyxovirus, member of rubeolavirus family. 5. Liver. Liver is the largest internal gland of the body. Outer largest organ. Skin. Developed from endoderm, normally weighs about 1 to 2.3 kilograms. It is located in the right side, upper part of abdominal cavity and below diaphragm. Lobes of liver. Right lobe, larger in size. Left lobe, smaller in size. Right and left lobes are separate by the falciform ligament. Right and left hepatic duct arises from right and left liver lobe. Both these ducts combine to form a common hepatic duct. Inside both lobes, small lobules are present. Lobule is the functional unit of lobes. Structure of lobule. Lobule is a hexagonal structure. 1. Central vein. Present at the center of lobules, so-called central vein. Hepatic arteries release the blood into the sinusoid and it moves into central vein. This type of flow of blood is called centripetal blood flow. 2. Sinusoid. Sinusoid is a narrow tube which is integrally attached to the central vein. Inside of sinusoid present a special type of cell which is called as Kupffer cell. It fights against infectious cells. 3. Portal triad. Every hexagonal lobule corner has 3 ducts, so see as portal triad. 6. Mammary glands. A functional mammary gland is characteristic of all female mammals. One of the secondary sexual characteristics of female paired structures, breasts, that contain glandular tissue in variable amount of fat. The glandular tissue of each breast is divided into 15-20 mammary lobes containing clusters of cells called alveoli. The alveoli open into mammary tubules. The tubules of each lobe join to form a mammary duct. Several mammary ducts join to form a wider mammary ampulla which is connected to lactiferous duct through which milk is sucked out. Lactation. The mammary gland of the female undergoes differentiation during pregnancy and starts producing milk towards the end of pregnancy by the process called as lactation. The milk produced during the initial few days of lactation is called colostrum, which contains antibodies, absolutely essential to develop resistance for the newborn babies. 7. Stomach glands, also K, as gastric gland. Mucosa of stomach contains the gastric gland, which is made up of different cells. 1. Chief cells, peptic cells, zymogen cells, secrete pro-enzyme pepsinogen, gastric lipase and pro-renin in children. Pepsinogen activated by HCl into pepsin. Pepsin digest proteins in children. Milk is digested by pro-renin, which is activated by HCl. Renin is also K, as chymosin. 2. Parietal, oxantic cells, secretes HCl and Castle's intrinsic factor HCl provides acidic medium 1.8, 1.5 to 3.0, which is necessary for the action of pepsin. Intrinsic factor necessary for the absorption of vitamin B12. B12 is necessary for erythropoiesis. 3. Mucus cells, goblet cells, secretes mucus and HCO3, which provide protection for the inner lining of stomach from excoriation of HCl4. G cells, secretes hormone gastrin, which increases gastric juice. 5. D cells, secretes somatostatin, it decreases gastric juice. 8. Eccrine sweat glands release salty water, sweat, through perspiration, release of water and salt from sweat gland. It helps to control body temperature. 9. Sebaceous glands. Your sebaceous glands are also on your skin, but they open into hair follicles. Sebaceous glands secrete sebum. Sebum is an oily substance that lubricates and protects hair and skin. 10. Cerumen gland present in ear, secretes ear wax. Cerumen, ear wax protects ears from physical. 11. Brunner glands. The Brunner glands are located in the first part of your small intestine, duodenum. The Brunner glands produce mucus that protects duodenum from stomach acid. They also help the body digest food and absorb nutrients. Connective tissue. Most abundant, widely distributed special function of linking and supporting other tissues, organs. In all connective tissue, except blood, the cells secretes fibers of structural proteins called collagen or elastin or reticulin. Mesodermal in origin cells secrete modified polysaccharide or mucopolysaccharide like hyaluronic acid, which accumulated between cells and fibers and act as matrix, ground substance, functions of CT, to connect structures, to form packing around organs, to form supporting framework, to combat, fight foreign toxins, to replace tissues which have been destroyed by injury. Fibroblasts are irregularly shaped flat cells with long protoplasmic processes. They secrete elastin and collagen protein fibers. Macrophages are amoeboid cells which destroy microbes, foreign particles and damaged cells by phagocytosis. Mast cells are ovoid cells that store inflammation-producing substances like histamines. The fibers found in areolar tissue are collagen and elastin. Collagen fibers have tensile strength and are also involved in tissue repair. Elastin fibers protect the cells from mechanical stress. 1. Loose connective tissue. It has more matrix, less fiber. The cells and fiber are loosely arranged in semi-fluid ground substance. It is of two types. 1. Areolar. 2. Adipose. A. Areolar connective tissue, also K. as spongy connective tissue. Most widely distributed in the body. Maximum intercellular space and matrix is present. Due to irregular arrangement of bundles of collagen fibers, many gaps are present. These gaps are seen as areola. In areola, mainly collagen white fiber and few elastic fiber are present. It contains fibroblast cells, macrophages and mast cells. It acts as a packing tissue in almost all the organs to keep the organs in place and in normal shape. It provides a medium for rapid diffusion of materials. It helps in healing wounds. Histamine attracts phagocytes to the site of infection. Heparin avoids blood coagulation. Histamine of mast cells is involved in allergic and inflammatory reactions. Function. It serves as a supportive framework for epithelium, i.e. present beneath the skin. X. Black small square tela subcutanea, a thin continuous layer which connects skin with underlying skeletal muscles. Punniculus carnosus. Black small square endomysium around single muscle fiber. Black small square perimysium around bundle of muscle fiber. Black small square submucosa of trachea, bronchi, intestine, esophagus, stomach. Black small square around blood vessels. B. Adipose connective tissue. Loose connective tissue, present beneath skin, contains adipocytes, fat cells. The cells are specialized to store fat. Excess nutrients which are not used immediately are converted into fat and are stored in tissue. Black small square on the basis of adipocytes. Two types of fats are found in animals. I. White fat. E. Brown fat. I. White fat. It is composed of monolocular, having single cavity, adipocytes in which single layer fat globules and less number of mitochondria are present, so they produce less energy. Examples: Punniculus adiposus, a thin continuous layer of white fiber under the dermis of skin, see as hypodermis. Yellow bone marrow. Fat bodies of frog, blubber of whale, hump of camel, present around eyeball, kidney, act as shock absorber. E. Brown fat. Multilocular adipocytes, which contain many fat globules, have more cytoplasm and more mitochondria. It produces 20 times more energy than white fat. It prevents heat loss. Example: black small square cold resistance in newborn babies. Black small square hibernating rodents like rat, shrew. 2. Dense, fibrous connective tissue. More fiber, less matrix. Fibers in fibroblast cells are compactly packed in dense connective tissue. A. White fibrous connective tissue. In this, collagen fibers are more in quantity, whereas yellow fibers and reticular fibers are completely absent. Fibroblast and mast cells are more in quantity. On the basis of arrangement of fibers and fibroblast in matrix, this tissue occurs in two forms. I. Cord. Many parallel bundles of collagen fibers, rows of fibroblasts are present alternately. X. Tendon, connect bones to muscles. 2. Sheath. In this form there is no regular pattern of fibers and fibroblasts in the matrix. Cells and fibers are arranged in a criss-cross manner. X. Pericardium, covering of heart, periosteum, outer covering of bone, perichondrium, outer covering of cartilage, epimysium, covering of muscle, renal capsule, around kidney, tunica albuginea, covering of testis, durmata, outermost covering of brain, glussons capsule, around liver, lobules, cornea of eye, tunica adventitia of trachea, bronchi, esophagus. B. Yellow fiber connective tissue. In this tissue, yellow fiber is more in quantity but collagen fiber are less in quantity. Reticular fiber are absent. On the basis of distribution of fibers and fibroblast in matrix, they are of two types. I. Cord. In this form, bundle of collagen fiber and fibroblast in matrix distributed in a regular pattern, and in matrix yellow fiber form network. X. Ligament connect bones. Sprain is due to excessive pulling of ligaments. 2. Sheath. Irregular distribution of fibers and matrix with elastic fibers. X. Wall of alveoli of lungs, wall of small bronchioles, walls of lymph vessels and blood vessels, true vocal cords. C. Reticular fibrous connective tissue, also C as lymphoid tissue. Mostly found lymphoid organ matrix is found in tissue like lymph. Reticular fiber are more in number and form dense network around reticular cells and macrophages. Lymphocytes are more in number, provide support and strength, and form the stroma, framework, of soft organs. X. Spleen. Lymph nodes, tonsils, Peyer's patches in intestine, endosteum, lining of bone marrow cavity. 3. Specialized connective tissue. Skeletal CT, I, cartilage, E, bone. It is of two types: vascular CT, I, blood, E, lymph, A. Skeletal connective tissue. Matrix dense and mineralized. Due to deposition of minerals it become hard. Supporting tissue, I, cartilage, outer covering C, as perichondrium, white fiber, matrix, intercellular material, is solid, pliable and can resist compression. Cartilage producing cells chondroblast, divided to form chondrocytes and matrix of cartilage. Chondroblasts are cartilage destroying cells. Chondrine matrix of cartilage, made up of chondroitin sulfate and mucopolysaccharide. Blood supply is absent in matrix in the matrix of cartilage but present in perichondrium. E. Bone, periosteum, outermost covering of bone, white fibrous tissue, osteoblast, bone producing cells divide to form osteocytes and matrix osteocytes, mature cell of bone, which is found in lacuna. Only one osteocyte is found in one lacuna. Osteoclast cells, bone destroying cells. Ossification, process of formation of bone. Bones have hard and non-pliable found substances rich in Ca+2 salts and collagen fiber, which give bone its strength. Osteology, study of bones. Features of bones: black small square highly vascular, black small square mineralized, black small square hard and rigid, black small square. It has regenerating capacity. Functions of bone: provide structural framework to the body, support and protect softer tissues and organs. Long bones serve weight-bearing functions. Interact with skeletal muscles to bring movements. Bone marrow, site of production of blood cells. Black small square. The bone cavity of long bones is called bone marrow cavity, and it is covered by a layer called endosteum, made of white fibrous tissue and osteoblasts. Black small square. The bone marrow cavity is filled with a semi-solid fatty neurovascular tissue called bone marrow. Black small square bone marrow is of two types, i.e., red bone marrow and yellow bone marrow. The black small square red bone marrow is highly vascular reticular tissue which synthesizes erythrocytes, hematopoiesis, and granular leukocytes. Black small square yellow bone marrow mainly stores fats. It performs hematopoiesis only in case of an emergency. Blood. Blood is a vascular or fluid, motile, connective tissue containing plasma and formed elements, free blood corpuscles or cells. The matrix is not formed by tissue cells and is devoid of fibers. The cells of blood do not have the power of multiplication, cell division. Blood is heavier than water and slightly alkaline in nature, pH range -7.36 to 7.54, average pH 7.4. Blood forms about 6 to 10% of the body weight. A healthy adult human has about 5.5 liters of blood. Hematopoiesis is the process of formation of the blood. In a mammalian embryo, the yolk sac, liver, bone marrow, lymph nodes, spleen and thymus are hematopoietic organs. However, in adults, most of the blood cells are formed in the red bone marrow. Blood transports food materials, respiratory gases, hormones, excretory wastes, and heat. It also maintains the pH, balance the amount of water, helps in healing, etc. Composition of blood. Blood is composed of 55% plasma and 45% formed elements. Plasma hollow circle. It is a light yellow, straw-colored, liquid consisting of 90–92% water and 6–8% proteins. Hollow circle. Major proteins present in blood plasma are fibrinogen, for clotting of blood, globulins, involved in defense mechanism, and albumins, maintain osmotic balance. Hollow circle plasma contains mineral salts, 0.9% of plasma, like chlorides, bicarbonates, sulfates, and phosphates of sodium, potassium, calcium, iron, and magnesium. Hollow circle. Many cellular products like enzymes and hormones, cellular wastes like urea, gases like O2, CO2 and nitrogen, and nutrients like glucose, fatty acids, amino acids, nucleosides, hollow circle. Anticoagulant heparin are also found in the blood plasma. Formed elements hollow circle. The formed elements of blood consist of two types of corpuscles, blood cells, namely erythrocytes, red blood cells, and leukocytes, white blood cells, and thrombocytes, platelets. A. Erythrocytes, red blood cells, RBCs, hollow circle. They are the most abundant blood cells, 5 million to 5.5 million per cubic mm of blood in a healthy adult human. Hollow circle human erythrocytes are small, rounded, biconcave and measure 7 to 8 meters in diameter and 2 meters in thickness near the rim. Hollow circle mature erythrocytes do not contain cell organelles such as nucleus, mitochondria, endoplasmic reticulum, etc. Hollow circle. The entire cell space is filled with a red-colored, iron-containing complex protein called hemoglobin, causing an increase in O2 carrying capacity. Hollow circle hemoglobin is formed of globin protein and in Fe2+ porphyrin complex. Globin protein is formed of 4 polypeptide chains minus 2 alpha and 2 beta chains. Each hemoglobin molecule contains 4 heme groups attached to each molecule of globin. Each heme group consists of an iron-containing porphyrin ring. The porphyrin ring contains an atom of iron and 4 pyrrole rings. An erythrocyte has about 280 million hemoglobin molecules in its cytoplasm, and only hemoglobin constitute 36% of total weight of RBC, 90% of dry weight. A healthy individual has 12-16 grams of hemoglobin in every 100 milliliters of blood. In humans, erythrocyte has a lifespan of 120 days. Worn-out RBCs or fragments of RBCs are disposed of by phagocytosis by macrophages in the liver and spleen, graveyard of RBCs. On exposure to a high partial pressure of O2 in the lungs, 4 molecules of O2 loosely bind to 4 Fe2+ icons of hemoglobin to form oxyhemoglobin. Oxyhemoglobin releases O2 at low partial pressure of O2 in the tissue. Some of the CO2 combines with globin or hemoglobin of erythrocytes and is carried to lungs. RBCs carry CO2 as bicarbonate ions formed in them by catalytic activity of carbonic anhydrase enzyme. B. Leukocytes, white blood cells, WBCs, hollow circle. These are the nucleated, colorless blood cells with comparatively short lifespan, 12 to 20 days. Hollow circle. They are relatively less in number, which averages 6,000-8,000 per cubic mm of blood. Hollow circle based on size, granules, staining reactions, shape of nuclei, etc. Leukocytes are classified into granulocytes, having granules in the cytoplasm, and agranulocytes, absence of granules in the cytoplasm. C. Thrombocytes, blood platelets, hollow circle. These are biconvex or rounded, small cell fragments produced by megakaryocytes in the bone marrow. Hollow circle. They are smallest in size, having a diameter of 2 to 3 meters. Hollow circle. The lifespan of platelets is about a week. Hollow circle. The colorless platelets number varies from 150,000 to 350,000 per cubic mm of blood. Hollow circle. The platelets release several platelet factors and an enzyme thromboplastin on injury, which plays a vital role in blood clotting. Lymph, TISSUE fluid. Some water and water-soluble substances move out of the blood into the interstitial space when the blood flows through the capillaries in the tissues. This fluid is called tissue fluid or interstitial fluid or lymph. Its mineral distribution is the same as that in blood plasma. Lymph does not have RBC and platelets. It has floating WBCs, mostly lymphocytes, which come out of the blood by diapedesis, the process by which WBCs pass through capillary wall. Lymph acts as an exchange medium which transports oxygen, food materials, hormones, etc. to the body cells from the blood and brings carbon dioxide and other metabolic wastes from the body cells to the blood. It keeps the body cells moist. Lymphatic vessels collect lymph and drain it back to the major veins. Lymph nodes produce lymphocytes. Lymph in the lacteals of the intestine absorbs and transports digested fat products and fat-soluble vitamins from the intestine. Muscle tissue. The muscular tissue is made of muscle cells or muscle fibers of variable lengths which are contractile in nature. Although the muscle fibers are bound together by connective tissues, they do not have any intercellular substance. Muscles help in the movements of the body. They help the body to adjust to the changes in the environment and to maintain the positions of the various parts of the body. Each muscle is made of many long muscle fibers arranged parallelly. These fibers are made of numerous fine fibrils, called myofibrils, present in the cytoplasm, sarcoplasm. A skeletal muscle, covered by a connective tissue sheath called epimysium, consists of many bundles of muscle fibers called fasciculi or fascicles, covered by perimysium. Each muscle fiber present in a fasciculus is surrounded by a thin connective tissue sheath called the endomysium. Based on the location, there are three types of muscles: skeletal, smooth, and cardiac muscles. Neural tissue help in body's responsiveness to changing conditions. It coordinates and integrates the functioning of various body parts. The neural system consists of neurons, neuroglial cells, neuroglia, ependymal cells and neurosecretory cells. Neurons are the structural and functional unit of neural system. A neuron consists of three major parts: cell body, dendrites, and axon. Cell body. The cell body consists of nucleus, mitochondria, endoplasmic reticulum, Golgi bodies, lysosomes, ribosomes, nacelles granules and neurofibrils in the cytoplasm. Dendrites. Dendrites are usually shorter and tapering processes of a multipolar neuron. They receive electrical signals from other neurons. Axon. Axon is a long process arising from the cell body. Its neuroplasm contains abundant neurofibrils and mitochondria but lacks nacelles granules and other cell organelles. The axon ends into terminal presynaptic knobs. The electric impulse travels along the length of the axon towards their endings. Neuroglia. Neuroglia makes up more than one-half the volume of neural tissue in our body. The neuroglial cells protect and support neurons. Neuroglial cells are majorly of two types: macroglial cells, astrocytes and oligodendrocytes, and microglial cells. Ependymal cells. Brain and spinal cavities are lined by a single layer of ependymal cells. They may be squamous or columnar and bear microvilli and cilia at free ends. The cilia and microvilli help in movement and absorption of the cerebrospinal fluid, respectively. Neurosecretory cells. Some nerve cells modify to secrete hormones in the blood. The neurosecretory cells of hypothalamus secrete many neurohormones which stimulates anterior pituitary. When a neuron is suitably stimulated, an electrical disturbance is generated which swiftly travels along its plasma membrane. Arrival of the disturbance or impulse at the neuron's endings, or output zone, triggers events that may cause stimulation or inhibition of adjacent neurons and other cells. Thanks for watching.